When we were factoring, we did a form that was the difference in two squares, or the difference in perfect squares. And we really looked at a lot of these numbers here, but these are the perfect squares, meaning these are the numbers where you can have a number times itself that equals that. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on. And we have perfect cubes. So we have seen these numbers before, but now we're not looking at them in regards to factoring, we're just looking at them with radicals or roots. So all of the roots that we looked at so far in section 8.1 were perfect squares or perfect cubes. So now we're looking at how to simplify roots where it's not a perfect square. And to do that, you want to factor out the largest perfect square that divides evenly. So looking at number 1, it's the square root of 12. 12 is not on this list. So what I need to do is I need to break it up into 2 square roots. The first square root has to be a perfect square, and then that's being multiplied by whatever I need to multiply to get back to 12. So it's kind of like multiple choice what you put in here. There's only so many different choices you can put in there. It has to be on this list. So 1 does, but that doesn't really help us. 4 does, 9 doesn't, and 16 is too big. So 4 is the largest perfect square that divides evenly into 12. And how many times does it go into 12? 3. So I haven't changed the value here, I've just split this up into 2 numbers multiplied by each other. I could recombine these if I wanted to. So then my next step is to actually take the square root of that perfect square. So the square root of 4 is 2 without a radical, and then I still have that square root of 3. So this is the exact value simplified of square root of 12. If you were to take the square root of 12 on your calculator, you would get a decimal, but that decimal is just an approximation of this. This is the exact value. The decimal is just an approximation, and they don't usually ask for the approximation. So in these we're just looking for the exact value simplified. Okay, so square root of 32, I want to break that up into a perfect square times whatever it is that gets back to 32. So I need to go down my list of perfect squares. 1 goes into it, but we don't care. 4 goes into it. 9 does not go into it. 16 does. 25, that's getting too big. 36 is definitely too big. So 16 is the largest perfect square that divides evenly into 32. And it goes in 2 times. So then you actually want to take the square root of 16, which is 4, without a radical, and then you still have that square root of 2 left over. We can really apply the same thing for cubes. Only this time I'm looking at my perfect cube list. So what's the largest perfect cube that divides evenly into 32? Again, I don't usually care about 1. 8 does. Does 27? Nope. So 8 is the largest perfect cube that divides into 32. And it goes in 4 times. Although I am forgetting my index of my root here. There we go. Okay, so the cubed root of 8 is 2, and I still have that cubed root of 4. So that'll be my answer. The cubed root of 54 the largest one that goes into it would be 27. So 27 times 2, and then the cubed root of 27 is 3. So this would be the simplified exact form.